Hello, my name is Pranay Raj from Department of CSCA. Today I am going to explain about solved examples of exact differential equations. Introduction to exact differential equations. An exact differential equation is of the form mxy dx plus nxy dy equal to 0, where dou m by dou y equal to dou n by dou x. This condition ensures the existence of potential function such that m dx plus n dy. Exact equations arise naturally in physics and engineering, especially in conservative systems. Solving involves finding phi xy equal to c, the implicit solution to the differential equation. Verification of exactness is the first step before attempting integration. Solution method. Constructing the potential function. To solve, find xy such that dou y by dou x equal to m of xy and dou y by dou y equal to n of xy. Integrate m with respect to x to get xy of xy. Integration of m dx plus hy, where h of y is an unknown function. Differentiate this result with respect to y and set it equal to n of x comma y to solve for h of y. Integrate h of y to obtain h dash of y to obtain h of y. Then substitute back to get the full. The general solution is I of xy equal to c, where c is an arbitrary constant. Example 1. Simple exact equation. Consider 2x plus 5 of dx plus x plus 2 of 2y of dy equal to 0. Check exactness. Dou by dou y of 2x plus y equal to 1. Dou by dou x of x plus 2y equal to 1. Equation is exact. Integrate m equal to 2x plus y with respect to x. Differentiate y with respect to y. Dou y by dou x equal to x plus h dash of y. Set it equal to n equal to x plus 2y. H dash of y equal to 2y. Integrate h of y equal to y square. Solution x square plus xy plus y square equal to c. In example 2, trigonometric exact equation. Solve sin y plus y cos x dx plus x cos y plus sin x dy equal to 0. Verify dou m by dou y equal to cos y plus cos x. Dou n by dou x equal to cos y plus cos x, which is exact. Integrate m with respect to x and integrate y. Integrate y with respect to y. Thus h of y equal to constant. Solution is x sin y plus y sin x equal to c. Example 3. Polynomial with mixed terms. Given 3x square y plus y cube dx plus x cube plus 3x y square dy equal to 0. Check dou m by dou y equal to 3x square plus 3y square. Dou n by dou x equal to 3x square plus 3y square, which is exact. Integrate m with respect to x. Integrate y with respect to y. Set that equal n. So the final solution x cube y plus xy cube equal to c. Non-exact equation. Need for integrating factor. Not all equations are exact. Y example. Y plus x dx plus x dy equal to 0 as dou m by dou y equal to 1. Dou n by dou x equal to 1. Actually exact. Note correction. Consider y of dx plus 2x dy equal to 0. Then dou n by dou y equal to 1. Dou n by dou x equal to 2, which is not exact. Integrating factor mu x or mu y can make it exact. If dou m by dou y minus dou n by dou x by n is a function of x only, use mu x equal to exponent integration dou m by dou y minus dou m by dou x by n dx. Multiply through by mu to restore exactness and then solve as usual. Example number 4. Using an integration factor which is a function of x. Solve y dx plus 2x dy equal to 0, which is non-exact since dou m by dou y equal to 1, dou n by dou x equal to 2. Compute dou m by dou y minus dou n by dou x by n equal to 1 minus 2 by 2x equal to minus 1 by 2x. It is a function of x only. Integrating factor mu x equal to exponent of integration minus 1 by 2x dx. Multiply equation by mu, which is integration factor of multiplying. The final solution is 2y x power 1 by 2 equal to c. Example 5. Integrating factor as function of 5. Consider xy plus 1 dx plus x square dy equal to 0. Now check dou m by dou y equal to x, dou n by dou x equal to x, which is not exact. Compute dou n by dou x minus dou m by dou y by n equal to 2x minus x by xy plus 1 equal to x by xy plus 1, not purely y dependent. Try dou m by dou y minus dou n by dou x by n equal to x minus 2x by x square is equal to minus 1 by x. It depends on x. So you can use mu of x. Multiplying with mu of x. After multiplying, the exact solution is xy plus log x equal to c. Applications: energy conservation in mechanical systems. Exact equations model conservative forces fields where total energy is conserved. For a particle moving under potential V of x comma y, the work done is path independent. The differential form F into dr equal to minus dv, which leads to an exact equation in coordinates. Solving these equipotential curves or trajectories in phase space. Such models are foundational in robotics and control system in AI-driven engineering. Application: circuit analysis and Kirchhoff's law. In electrical circuits, voltage drops around loops sum to 0, analogous to exactness. Differential forms of current and voltage can yield exact equations in dynamic systems. RLC circuits with energy storage elements often reduced to exact or integrable forms. Solutions describe steady-state behavior or transient responses in AI hardware design. By understanding exactness helps verify consistency in circuit modeling equations. Such models are foundational in robotics and control systems in AI-driven models. Solving these equipotential curves or trajectories in phase space. Common mistakes and pitfalls: failing to verify exactness before integrating leads to incorrect resolutions. Incorrect integration limits or forgetting the arbitrary function h of y or g of x. Assuming all first order equations are exact, many require integration factors. Misapplying the integrating factor formula by choosing the wrong variable dependency. The algebraic errors in partial differentiation or integration are frequent under time pressure. The summary of exact differential equations and the key takeaways. Exact equations satisfy dou m by dou y equal to dou n by dou x and are solved via potential functions xi of x comma y. The solution method involves systematic integration and differential steps. Non-exact equations may be converted using integrating factors dependent on x or y. These equations appear in physics, engineering, and system modeling, highly relevant to AML infrastructure. Mastery of exact equations builds foundation for advanced topics like PDEs and vector calculus. Thank you.